let's pick up where we left off last time. So, all of that information about convection currents and all of Alfred Wegener's hard work in coming up with the hypothesis of continental drift, that's all been put together in what makes up plate tectonics. Okay? All that information is what upgrades it to a theory. Unlike the hypothesis of continental drift, that key piece of convection currents was the huge chunk of evidence that we needed to support that plates and continents can move. And these plates are moving constantly every single year, but only about like 1 to 12 centimeters, so little tiny squicks. Depending on who you are, there's a chance that your hair or your nails end up growing faster than what these plates end up moving per year. But all this movement is going to make earthquakes, volcanoes, and as you saw, mid-ocean ridges and deep ocean trenches. If you are able to look at this picture and you can see that from the movement of these convection currents, the plates are moving away from each other, and you can say that's a divergent boundary, and that's like where a mid-ocean ridge is and seafloor spreading takes place, you're going to be pretty good to go on this next test. Same thing if you can look at this part of the picture and you can say, all right, those plates are converging at a convergent boundary, and there's a chance that there could be a subduction zone there, like at a deep ocean trench. You're probably good to go and ready for this next test, because that is, again, as hard as it is ever going to get in this chapter. Here, you've just got another picture of the same stuff showing you a different way that it might be represented on a test question or pop up on TCAP. Same stuff. So let's finally talk about these three boundaries. We've discussed divergent, we've discussed convergent, but now our third and final one is the transform boundary. It's a little bit harder to see, but not too bad to imagine. It's two plates sliding past each other in opposite directions. Okay, so again, divergent is goodbye, convergent is hello, transform is, oh, please get out of my way. So that's all there is with those three boundaries. And at the bottom, I included the word fault, just so you've heard it before, because we're going to be dealing a lot with faults in the next section of this big unit. So anywhere there's a crack in the crust, that doesn't mean just at these three boundaries. It could take place anywhere in the plate, including the center. Okay, that's any crack that's in the crust due to stress and whatnot, because they're moving. Little recap still going on here. Divergent boundaries, they are diverging away from each other. This is going to occur at mid-ocean ridges, so the seafloor can spread and you can make more floor. Okay, there's going to be a lot of volcanic activity around this, and if it takes place at one of these areas where there are lots of faults, it can make something called a rift valley, and there's a really pretty one in Africa that you can look up some pictures on Google Images if you want to. And with convergent boundaries, you may have noticed in the pictures that it would label some portions of the crust as continental crust, some portions of the crust as oceanic crust, and who might win in each of those struggles? Well, there is a definite winner in each of those situations, kind of. If you've got oceanic crust versus oceanic crust and they collide, the older, colder, denser crust is going to be what's pulled and subducted into the mantle. If you have oceanic crust versus continental crust and they collide at, again, a convergent boundary, the oceanic crust is going to get subducted because it is more dense. And the more dense something is, the more likely it is to sink due to gravity. But if you have continental crust versus continental crust and they collide, you're going to get mountains. Okay, that's exactly what happened when the subcontinent of India slammed right into Asia. It created the Himalayan mountain ranges that are actually still getting taller because of this convergence. And last but not least, once again, there are those transform boundaries where they're trying to slide past each other in opposite directions. And because you're dealing with crust, rocks, things that are not nice, neat, pretty, and smooth, they're going to get like caught and hung up on each other, and it's going to be jagged, and you're going to have some tension there, and eventually it's going to unlock and they're going to be able to move past each other. But all that stress and tension, when it's finally released and able to unlock, that's going to be what triggers some major earthquakes. But here, unlike at a divergent boundary where crest is made or at a convergent boundary where crest is lost. It's just kind of there. It's neither created nor destroyed at a transform boundary. And that's it. That's everything in this portion of the unit. So hopefully you guys are able to hang through those first two really, really long videos for this one, and everything makes a lot of sense. And if it doesn't, shoot me an email, write me something in Google Classroom, let me know if you got questions, and I'm more than happy to help you. But thanks for sticking it out, guys. Bye.